All right, today I want to talk a little bit about the kinematics and compatibility for reinforced concrete. So recall, for reinforced concrete, we're talking about having steel rebar inside a concrete cross-section. Now we want to come up with a general procedure to calculate the axial strength of these sections when we have some sort of force, say in a column of a reinforced concrete structure. All right, we said with the steel, right, we use deformed rebar. So this makes sure that both the steel and the concrete act as one, or that both materials will undergo the same deformation or the same strain. So this is what we refer to as strain compatibility. For our section, for axial strength, we're considering our deformations in the direction of the column. So the general procedure will be a 4-part process. Step 1 is basically to assume a strain that is applied to the cross-section. So, and again, if we have true strain compatibility, then this strain will be the same in both the steel and the concrete. All right, once we have the strain, we want to convert that to stress. So we need to have some sort of model. So we talked in class about some of the different stress strain curves we could use for each material to determine the stress in that material. So for concrete, we talked about the Todeschini curve. So in this case, we take the assumed strain and we enter into some sort of function for the stress in the concrete. This was a parabola. And if you recall, this was a parabola and it had had different variables, including epsilon 0 and f prime c, that would allow us to then determine the stress in the concrete at any strain. For steel, we'll assume an elastic, perfectly plastic model. So in the elastic range, the stress in the steel is equal to the modulus of elasticity times the strain. And once we exceed the yield stress, then we cap the stress in the steel at the yield stress. All right, step 3 will now be to take this stress and using the area of the concrete and the area of the steel to determine the total force that each of these materials can carry. So for the force in the concrete, this would be the stress in the concrete times the area of the concrete. And for the force in the steel, this would be the stress in the steel times the area of the steel. Then in our final step, we'll just basically add these two forces together. So we'll take the force in the concrete plus the force in the steel, and this will equal now the total force that the reinforced concrete column can handle.